content. They used to be pretty good outlines, but then I couldn't find anything in my size.
And it's like, hey, maybe you should just stuck to the code factory instead of.
Okay, let's go ahead and get started.
Awesome.
Over the weekend, like I think it was on Thursday or Friday, did you guys get the document that I sent you that was like a review sheet?
Yes,
Yeah, I didn't look at it, but
What?
I got it.
You got it? Did you get it?
I looked over it.
Yeah, but you got it, right? Okay, so what's going on with it is that I had at that point seen the IB Tech final and wanted to at least like start you guys on the path of understanding that. Let's talk for a minute here. You know, the good book says man cannot serve two masters. He'll either love the one and hate the other, or hate the one and love the other. Well, okay, we serve two masters here, right? We have to make IB Tech happy, and we have to make EBSC happy. You would think part of that is IB Tech writes a final for this class, and EBSC writes a final for this class. Well, in general, and therefore we have to have both of those finals, but we still only get an hour to take them. Okay, right off the bat I see a problem, right? Secondly, okay, you would think the IB Tech version of the class is for college and the EBSC is for high school. So if we were to draw, say, a Venn diagram of material on the final, you would be very rational for thinking that like EBSC would be a smaller amount of material than IB Tech, right? That would be a very rational thing to think, except for one thing. Finite Math is a 2-semester class in high school, and it's a 1-semester class in college. So EBSC's goals for the class are somewhat bigger than IB Tech's just because they have more time, right? So how do these two subsets overlap? It turns out the IB Tech final is somewhat smaller than what the EBSC is asking about.
Because one hasn't anything previous even rational.
What did you say?
One has
Oh, well, whatever. I mean, it's rational. They're thinking we have 2 semesters to cover the material, right? So, all right. That makes perfectly good sense so far. Except, holy crap. So not only do we have EBSC's final, I'm sorry, IB Tech's final, which IB Tech students get an hour and 40 minutes to take, and we get an hour and 10, but you also have to answer EBSC's questions. You see how I'm starting to get a little anxious about this whole thing? Okay, so, to make some measure of peace about this, I've been in communication with the folks at downtown who are running the math stuff, and our final will be more like this. Okay? In other words, it's the IB Tech final with, instead of asking all those EBSC questions that are quite similar but not exactly the same question as what's on the IB Tech final, we'll kind of count that both ways, and we just have to cover the stuff that's more than what we did on separate questions. Does that make sense? It does not mean that the test isn't big. It's still kind of big, but it could have been so much worse. Do you understand what I'm saying here? They kind of met us more than halfway on this, right? If IB Tech has a question that was pretty much the same thing EBSC was asking, they got rid of the EBSC one. Okay? So this is good news-ish. It still means the final's kind of big, in my opinion. On the other hand, it means that it could have been so much worse. Okay, so if you looked at the handout that I sent you guys over the weekend, what you saw was that I gave you a pretty specific list of the kinds of things that were on the IB Tech final. Okay? I'm not going to tell you I had the IB Tech final in front of me when I wrote the thing. I wouldn't tell you that. You know what I'm saying? Make sense? All right. On the other hand, I also at the bottom listed some things that were not on there. What you'll notice is IB Tech covers a couple fewer chapters than we do. For example, they don't do any of the simplex stuff. Okay? They do linear programming the graphical way. We'll talk about that in a little bit. But they don't do any of the simplex stuff. We won't either on the final. Okay? The simplex stuff is cool, and you've already done so many examples of it and been tested on it extensively. and been exit ticketed example. There's no shortage of documentation of how you guys do on simplex stuff. We don't need to make the final ginormous by having another one of those. Okay? Ivy Tech also does not get through the Markov chain stuff. Okay, we do need to have Markov chain questions on the test. That is an EVSC goal for the course. We have to have that. Okay, so that has been added, and we'll talk more about that today. And also we have a review on Wednesday as well. That's good. I can't remember how much. Well, let's just go through the review sheet. If you don't have the review sheet in front of you that I sent you, that's okay. We can talk about it. Okay. Again, we're loving one master and hating the other, or hating the other master one and loving the other. I don't exactly know how to feel at this moment.
I'm hating both of them.
I am too, actually. Wait till you hear the story about pre-calc. We're going to have Venn diagram talks in all my courses this semester. Yeah, the diagram's a whole lot. Wait till you hear this thing talk about earth science next semester. Holy crap.
Oh boy.
Let me give you the diagram for earth science and for at Ivy Tech and earth science at. So here's Ivy Tech's earth science, and here's EVSC's earth science. They basically don't even seem to agree what the hell earth science is. There's just this little bit in common, and so they want all this stuff, and EVSC's no, I want all of this stuff. So by the way, get through all of that material. Basically, get through 2 versions of earth science in one semester. Anyway, moving along.
I mean, why not teach everything at the same time?
I don't understand.
We're all going to be confused anyway.
I know, Ivy Tech's version of earth science and EVSC's, their list of goals are weirdly different. I don't understand. And both of them are weird. It isn't like Ivy Tech's weird, and it isn't like EVSC's weird. Like, EVSC's earth science has a whole unit on astronomy.
Oh,
Astronomy is a whole separate thing.
I did a repeat.
Yes. Well, we're going to move through it really fast. Because Ivy Tech doesn't give a damn. They don't want earth science in there. I mean, astronomy. They teach a separate astronomy course. And so they don't care that, but no, to make it count for EVSC's earth science, we have to have. Okay, moving along. All right, so the first thing that was on your review sheet is about graphing inequalities. That's when you have something like, oh, I don't know, x plus 3y is less than 10. Okay, and we did these guys in the context of linear programming techniques. Where we did, the idea, again, if you haven't looked at the review sheet, is this is going to be an area on a graph. The best strategy for doing these kind of things is to rearrange it as if this were an equal sign. So we can go ahead and subtract the x from this side, and we can go ahead and divide by the 3, and then just treat this like a line. So the y-intercept is at 10/3, and the slope is -1/3, and it looks something like this. Then you just have to figure out, is it above or below the line that gets shaded in? And in this case, it would be, because this is, so you want your y to be less than this, so these are places where the y is, go through here. That's all it is. It sounds a little scary the way it's worded on the test, but that's all it is. When in doubt, when I have such a problem, I check my work by trying an easy case. Like, for example, to make sure I shape, I'm pretty confident about where I drew this line, but I tend to get freaked out about it. Should it have been the area above or below that counts? Yeah, Andrew.
It's like less than or equal to, do you have a dotted line?
Yes. There was no guidance about that on the Ivy Tech final as to whether they're, in this case, it would be less than, so it's this dotted line thing. Whereas less than and equal, it would be solid. There was no guidance for the teachers as to when we graded, should we get bent out of shape about that. Okay? But you're right. When I'm doing this though, like I said, to check to make sure, I tend to get freaked out about should it have been the top half or the bottom half. I try something easy like 0, 0. Should 0, 0 be in the region or out of the region? 0 plus 3 times 0 is 0. 0 is less than 10. That works. So this should be in the region, right? So I usually check something quick like that. All right. This comes up twice on the test. Well, in two separate places. I don't remember if it's more than one question or not on each section. Because this is also linear programming. Let me skip right now what happens next on the review sheet and talk about linear programming. Remember, linear programming was the kind of stuff that we were solving using the simplex method. Now, simplex method itself is not on the test because that's just not really testable material, okay? I mean, you have to have your book open. By the way, as far as I can tell, the test is closed book. Again, I have messages out about that. But having looked through it, I'm not sure the book being open would help. None of the questions on the test that Ivy Tech has sent out to all the schools seem to be the kind of thing like where you need that numbered list of 10 steps, that kind of thing. Or like you need Bayes formula in front of you or something like that. Okay. All right. These linear programming problems were the kind where there were constraints and then there was an objective function and you're trying to either maximize or minimize the objective function subject to those constraints. So for example, if we were just doing this with variables and so on, maybe for some reason x plus y has to be less than 5. You know, like maybe x is the number of hours we spend on this, and y is the number of hours of this, and there's only 5 hours in the day. Okay? And maybe 2x minus y is less than 8. And of course, we always had this constraint that these things had to be positive. And then there was some objective function based on those, like z equals, let's just say, x plus y. And we were trying to, let's just say, maximize this. Oh, I'm not sure I'm off entirely on the screen here. Hold on. Let me just, since we have at least 2 people who will be watching it, let me just move this over a little bit. So here was the problem we're solving. We had 4 constraints. Then we had 2 variables. And then we had an objective function. In this case, the z here is the objective function, x plus y. All right. Now, we learned all kinds of steps of the simplex method to solve this, and it was lovely, but that's not how we did this one. Remember, when they only had 2 variables in the constraints, we could do this graphically. There is, I forget which verb to use here because I don't remember if it's 1 or more, questions on the test that involve doing that. So what we would need to do is make a graph here where we graphed these areas and we find the feasible region. Remember that term? The feasible region where values of x and y meet all of those constraints. All right, so probably our path of least resistance here is to rewrite these guys into a form that involves looking a little bit like y equals mx plus b. Let's see here. Oh, I made something interesting here without realizing it. Hold on. Hey, wait a minute. What about this negative over here? What am I going to do about this guy? Oh, well, I could divide by -1 or multiply by -1. But remember, when you multiply or divide by a negative number with these inequalities, you have to flip the direction of this. The inequality symbol reverses. I don't remember if that happens at all on the test or not. We can talk more about that on Wednesday if needed. All right, so once you got these guys, you graph them. Okay, so let's see, this first equation right here. Y is less than -x minus plus 5. So let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. The y-intercept here is at 5. Slope is something like this. And our area is this part. And then let's just label this corner here. This is at 0, 5, and this is at 5, 0, I believe. So that's this one. And then this one, 2x minus 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Minus 8's right here, and 2x. Let's see here. So the slope is going to be through something like this. Let me see here. I think it comes through about here. It's going to come through here like this. We'd have to actually find these points. Why do we need to know those corners? Because once we have the feasible region, remember then the feasible region is this area right here. In that area, all the points meet all those constraints. And then all you do is you plug in the values of x and y at each of these 4 sets of corners here, and into this function, and one of them will have the biggest value of z. Okay.
Will we do all this on like by hand?
I am still trying to figure that out versus using Desmos or something. I've still got messages out about that. Okay. If I remember right, the problem doesn't seem that bad. Okay, like the functions are pretty straightforward. It wouldn't be all that hard to graph them and find the points. Okay, whereas I just pulled these numbers out of my head and they're not that round of numbers and all that kind of stuff. Right. But yeah, so I have messages out asking if you're supposed to be using a graphing. Here's the deal: you almost certainly are allowed to use a calculator, and these days the word calculator is a synonym for graphing calculator. And how is graphing calculator different from Desmos? Right. So my guess is the answer is. Do you guys know how to use Desmos, like on your phone or whatever? Is there anybody who doesn't know how to use Desmos? Yeah, you've been using it to death, right? I mean, if you needed to check something like this on your phone, I don't know how I'd stop you. You know what I'm saying? So my guess is the answer is it's going to be fine, but I have to actually hear that from somebody and have it in the file attached to the test and all that kind of stuff.
I mean, if not, you can always borrow a calculator from somewhere.
Yes, I know. That's the other thing. Is are they going to say, no, you have to use like those box calculators that Mrs. Webster has? But I'm guessing they're going to say, you're not familiar with those calculators, therefore, that's not entirely fair on the final, therefore you can use your phone. Because I don't think Ivy Tech has those kind of things. I think that they all just buy their own calculator or use it on their phone. I'm really not that worried about it. I think it's going to be fine. But I do have to actually get an email message that confirms that. Okay. So that's what we mean by linear programming. I really didn't love that word linear programming, to be honest. I think that word doesn't really make it obvious that this is what we're talking about. Okay? But when it talks about like use linear programming to solve a problem or whatever, this is what it's talking about. You find the feasible region through using those inequalities, and then you just plug the corners of that the vertices of that feasible region into your objective function. So here you would try it. X plus y is 5. X plus y is 5. Oh, I'm sorry, this one. I'm guessing it's this one here, but I'm not. Actually, no, it's going to be a tie between these two. These are both going to add up to 5 in this case. All right. But anyway, you just plug them into that objective function. And we can do more examples of that. Maybe on Wednesday we will. Okay? All right, so that is as far as they take it on our final. Thankfully. I would not want to go back down that whole path of simplex stuff. That's one of my favorite things to teach, but it doesn't really lend itself to testing very well. It lends itself more to like projects and stuff. All right. If you take a look at the review sheet, the next whole chunk of stuff is about matrix operations. What you can do with matrices, how you do it, and so on. The problems that they give you look just like the kinds of problems I gave you on tests about that and so on. Things like, here's an example of A, let's say A is 1, 1, 1, 2. Let's say B is 1, 0, 0, 0, 2, 3. And C is 2, 2, 3, 3, 3, 3. All right. And then I will say things like, evaluate each of these if possible. If not possible, say impossible, kind of thing. All right, so what is A plus B? Is A plus B even possible? No. Remember, to do addition, they have to be the same dimension. They have to have the same number of rows and columns as each other. So A plus B is not possible. What if, just out of curiosity, it said like A plus A? Well, then that would literally just be this plus this. Remember, then you just add it element by element. So this plus this is 2. This plus this is 2. This plus this is 2, and this plus this is 4. You can only add the matrices if they have exactly the same number of rows and columns as each other. And then when you can add them, you just add them element by element. So what's in the first row, first column? Second row, first row, second column. Just add them up like that. I don't think any of that will freak you out. Nor do I think scalar multiplication will freak you out. I mean, if it was 7a, all you do is you just multiply element by element by 7. So 1 times 7 is 7, 1 times 7 is 7, 1 times 7 is 7, 2 times 7 is 14, and that's all there is to it. Again, it's not that hard once you just remember, and it should be relatively easy points. The one that might freak you out, because it kind of depends on whether you've done it recently or not, is multiplication. Now, allow me to tell you a story. We learned about scalar multiplication, like what we just did with 7a. And we learned about multiplying two matrices like we're about to do. There is a third thing that we did not need to do called the cross product. Okay, a third way of multiplying matrices. Here's the deal. It's not even in the index of your book. We never saw it this class. Here's the deal. The example they have of it on the test is not even a possible anyway. So what's the point? Okay? Now, so here's the deal. I can't change their questions, but I can change how we choose to interpret them. And I'll make this more clear on the day. I'll clarify this on the test. But just so you know, so you don't freak out when you see it, there is a problem on the test that says something like A cross C. And we're going to pretend we don't see the cross. When it comes time, I want you to evaluate that as A times C. Okay, just like what we're about to do now, matrix multiplication. I personally strongly suspect that it's a misprint. If it's not even in the book, I think the person who typed up the test, some grad student who works for Ivy Tech in Indianapolis or something who types these tests up, I think they made what's technically called a boo-boo. I don't think there's supposed to be a cross in that problem. But I literally don't have the edit permissions to change it. Okay? But that doesn't change the fact that nobody's really going to come and look over our shoulders and make me... So here's the deal. I will be clear about that when we get to the test. I'll shout it at you. But when you see that cross, it just means multiply. Let's just use multiply instead. All right, so how would we do this? What is 1, 1, 1, 2 times 2, 2, 3, 3, 3, 3? First off, is it even possible? Do you remember the trick for figuring out if it's possible? The trick is you write down the dimension of each of the matrices. This is a 2 row by 2 column. 2 by 2. So C, 2 row, 2 column. I'm sorry, 2 row, 3 column. It is possible to do the matrix multiplication if these two inner numbers match. In this case, they do. So it is possible to do the matrix multiplication. And the result has this dimension. It will be a 2 by 3 matrix. That little trick will help you know really quickly whether it's possible or not. Alright, so in this case, it's going to be a 2 by 3. We haven't done this for a while. We've been relying on that mmult function on Google Spreadsheets. If you don't remember, we get the value in the first row, first column by using the first row and the first column. And we compute the sum product here. This times this plus this times this. 1 times 2 plus 1 times 3 is 2 times... 1 times 2 plus 1 times 3. 2 plus 3 is 5. Alright, now we need first row, second column. First row, second column. 1 times 2 plus 1 times 3. 2 plus 3 is 5. First row, third column. 1 times 3 plus 1 times 3 3 plus 3 is 6. Second row, first column. 1 times 2 plus 2 times 3. 2 plus 6 is 8. 1 times 2 plus 2 times 3 is 8. 1 times 3 plus 2 times 3 is 9. That's all we need. And you get points. Moving fast kind of points, right? Oh my gosh. Who actually read the review sheet over the weekend? Good for you. Good for you. You probably started having chest pains about Gaussian elimination. Gauss-Jordan elimination. How'd you feel about that, MJ?
Well, I just kind of thought, oh boy, we're also going to be talking about it.
Yep.
So,
MJ hated that stuff a couple of weeks ago.
I mean, it's easy now.
Yeah.
But like, I still.
Because she's
don't
doing it
like
in brick up, yeah.
I still don't like it, and it's funny watching the.
Yeah, you think it's funny?
Strokes over.
All right, let's do a Gauss-Jordan problem. Gauss-Jordan elimination is when you have equations and variables, and let's see, the actual problem they use on the test has 3 variables and 3 equations. Let's cheat. Let's cheat. Let's know the answer and make it work from there. So let's cheat. Let's make it so over here we're cheating. We know in advance the answer is x equals 1, how about y equals -1, and z equals 1. We already know that's the answer, because that's really how these things are made, right? They really come up with the answer first, and then make a problem around it. So let's do that too. Well, okay, let's make a system of 3 equations with 3 variables. How about x plus y plus z equals 1? Because, see, that's going to work, right? X plus y plus z is going to be 1. How about 2x plus y plus z equals 2? And how about x minus y minus z? X minus y minus z. That negative, is that 1? Yeah, I think so. All right. We've made a system of 3 variables with 3 equations. So that's what you would see on the test. You would see this not knowing this stuff up here. What does it mean by Gauss-Jordan elimination? That seems like a good time to look in the book. When in doubt, look it up. Solution of linear systems by Gauss-Jordan elimination, page 54 to 70. That's a rather large chunk of pages. Section 2.2, solution of linear systems of equations by the Gauss-Jordan method. Hey, wait a minute. That Gauss-Jordan method, that's that one where you use the augmented matrix. That's the one where you rearrange this equation, where you just write the coefficients down. Make yourself a little fence here, and write those coefficients down. All right. Lovely. Now what? What is the whole goal of this thing?
Make it look like an identity matrix of the answers on the right.
Is that what the idea, the goal is?
But you don't have, you're still doing Gauss-Jordan, right?
Yeah, we're
You
doing
don't have
calc.
to put it in a matrix, do you?
Yes.
For Gauss-Jordan.
Gauss-Jordan is the one where you do this augmented matrix.
It's not
Oh,
low
wow.
echelon.
It is, well, we want to go, let's see here. Hold
I
on.
thought Gauss-Jordan was where you just like make it a triangle thing.
Yes, that's where we're headed on this here. Now, okay. Here's the deal. Hold on. Okay. MJ was more right than I was giving her credit for. Or somebody was. I don't remember which one of the two had said this. All right. The idea is we're going to do steps until the matrix looks like this. And there's stuff here. And the reason why we do this is we're going to do row operations on this matrix until we get it in that form, because then the stuff here, these are the answers. If you get it so that this part over here on the left side of the fence looks like an identity matrix, the stuff on the right makes it look, will have the answers. That's Gauss-Jordan. Okay. You are right if we've had different ways of solving problems before. I mean, we all had like 4 or something like that methods.
Oh no, I just got all the names.
Oh no, I do too. I get them turned around all the time. This is the one that the test is about. Alright, so we need to start getting rid of some stuff here. Like we need to get rid of this 2 here. But getting rid of this 2 won't be so bad. I mean, if we go over here and we make, let's see, twice row 1 minus row 2 becomes the new row 2. I mean, that's not so bad. As these kind of things happen, right, we're going to take a row operation. We're going to just do, well, let's actually, we're not going to change row 1 at all. And row 2 will be twice this minus this. 0. See, we've got one of those zeros already. Twice this minus this. 2 minus 1 is 1. Twice this minus this will be 1. Twice this minus this is 0. Okay, did that right? Twice this minus this. Twice this minus this. Twice this minus this. Twice this minus this. Okay. Hey, while we're at it though, there's no harm in doing the second one too, bottom one too. I mean, we know we got to get rid of this thing. How about row 1 minus row 3 becomes the new row 3? This is like the bleakiest, inkiest marker I've ever seen. All right. This minus this, 0. This minus this, 2. This minus this, 2. This minus this, 0. All right? I've done something bad. Hold on for a second. Okay. All right. I will not continue to move through these steps for now, because in a very dark and subtle way, something has gone wrong. And yeah. In a complicated sort of way, this set of equations is not solvable. I needed to come up with different equations than this. Do you see why something is wrong here? Just out of curiosity, do you see why anything is wrong here? This is not going to be a solvable thing. If I took this equation and my next step I said divide h by 2, do you see how this would become 0, 1, 1, 0? But then I'd have the same equation in 2 places? That's never a solvable thing. Okay? I can't remember, there's a word for this. This matrix is uninvertible or something like that. There's a word for this. This particular problem we can't solve this way. Okay? If I had chosen different equations up here, we could have solved it. I don't want to reinvent the wheel and spend all day on the Gauss-Jordan. The point is, these are the kinds of things, though, just to remind you as to how we get from point A to point B. And eventually you get to this. And these numbers here will turn out to be 1, -1, 1, assuming I had come up with better equations here. I just happened to make a poor choice on those equations here. I can't actually see what went wrong here. Somehow or other, though, we've done something bad here. And I don't mean we made a mistake. I mean, we just happened to make one of the problems. You might remember when we saw all of these methods, like substitution, elimination, Gauss-Jordan, and all that kind of stuff, there were like some caveats, like certain kinds of problems can't be solved this way. I made a boo-boo. We made one of those kind of problems. Okay. Obviously, in the test, they won't have done that. Let me take a look for a moment at the test. Okay. Let me tell you about the problem they have on the test. I'm hoping none of you have good eyes. There. That's the problem. 3 equations with 3 variables, just like the kind of one I wrote up there on the board. But that's all the space they give you. See, that's a new problem below it. So obviously we'll have to have you guys use scratch paper or something like that, okay? That you turn in with the test. One moment. Oh, okay, Google. What is 2 plus 3 plus 3 plus 3 plus 7 plus 7 plus 2 plus 2 plus 2 plus 2 plus 2 plus 8 plus 6 plus... You're not listening to me, are you, Google? I am strongly suspicious that the answer is 100. I think that this test is out of 100 points, and the Gauss-Jordan problem is 7. Well, hell damn crap, right? That seems a little... if I had been writing this test from scratch, I would not have made it worth that much. Isn't it an interesting thing that we learned? Is it like one whole letter grade of your final kind of interesting? No, I don't think so. There's no guidance as to how to grade it. Obviously, getting it set up will be a big chunk of your 7 points. You know what I'm saying? Like, understanding how, if they gave you this, getting it to this will be worth something. Making some steps on the way towards this will be worth something. Obviously, I can't give you full credit for it unless you get all the way to the solution. On the other hand, I can give you a lot of points even if you don't get all the way to the solution. Does that make sense? Because there's no specific... Sometimes on these kind of things, there's a specific guidance. Like, give them 2 of the 7 points that they get this far. Give them 3. This time there is nothing like that. Okay? I think this test is where this one was worth too many points. I would not have made this a 7-point question. All right, moving on. If we look further at your review sheet. Hey, wait a minute. I'll have to fix that. All right. The next part you'll like a lot better. Sets. We have a handful of fun questions, and it adds up to like 10 points of things about sets. So, markers right in my pocket already. All right. So, for example, A is the set 1, 2, 3, 4. B is the set 3, 4, 5. And let's say the universal set is the numbers 1 to 7. All right. In other words, those are all your choice. Maybe these were days of the week or something like that. Okay. What would be the intersection of A and B? Oh, these symbols, we hate that. These terms, these intersection. What was the intersection then of A and B? It's the ones that are in both, right? When you're at the intersection of the road, you're on both Buena Vista and First Avenue at the same time, right? So it'd be whatever is in both. Okay. What is B union A? Union means either, right? So it's in whatever is in either of them. So one, hey, by the way, did I make a mistake here? This is actually 3 and 4. Yeah. So this is 1, 2, 3, 4, 5. What symbol did we use here for complement? I mean that sincerely because I don't remember. I remember we used a different symbol in this class than we did in quantitative reasoning. What was the symbol for like not, or everything that's in the universal set that's not in this one? Was it the tilde? Let's actually look on the test. Tick mark. That's right. What is a tick mark? Which means complement. Complement means everything that's in the universal set that's not in this one. So a complement is 5, 6, 7. Oops. By the way, notice the little squirrely, tiggly, the curly braces? I was talking to someone from math at Ivy Tech, and they were all bent out of shape that you better know it's curly braces. Don't be making no damn parentheses. There are hills to die on. I'm not sure that the fact that it is curly braces, not square braces, not is parentheses, is the hill I would want to die on.
You're getting lightning bolts, and that's fine.
What?
You're getting lightning bolts.
Lightning bolts. As long as it's clearly not parentheses, I think I'll be fine with it, whatever. How far do they take this? They do have some that get a little bit. Let's just say we had a third option here. How about C is 1, 7? So they have things on here like C intersection A union B. Okay, so you just got to do this. Okay, what is A union B? A union B. So this is C intersects with A union B. A union B is 1, 2, 3, 4, 5. So the intersection of 1, 7 with this will just be 1. Okay. They do take it that far. But in the great scheme of things, that's 10 points on the test. All these set notation things. I do see one more thing that's on there. I don't know, cardinality. Remember cardinality? That's like, what is n of A? That's how many, the word for that was cardinality. That's how many members there are to this set. What is n of A? 4. What is n of C? 2. Things like that. Okay? Hooray, you just gained like 10 points on the test. Okay? I don't think anybody's going to miss any of those problems. Alright, so we're looking on here. Be able to solve a story problem using the Venn diagram. Okay. Because I know nobody has eyes well enough to see from over there, you'll notice there's a Venn diagram, there's verbiage above it, there's stuff on the Venn diagram, and then there's points down here. If I remember right, that went really well for people on the test that was about sets and probability. I mean, how many students liked both Spanish and German? How many students liked Spanish but not German? How many students liked French and German? That kind of thing, you know, when you have the information on there. All right. I don't really envision that being a problem that people get wrong, unless, of course, they just in general are freaking out because, you know, test anxiety. Weirdly, again on the subject of, really, is this the hill we want to die on? There's yet another whole page of Venn diagram stuff. I don't know that I think Venn diagrams would have come to 8, oh my god, 10. So 20 points of the test are Venn diagrams.
How many points is this?
And look, I think it's a 100-point test.
Wow.
Yeah, I'll have to add that up. But 20 points, I know. Would you have thought 1/5 of the test should be Venn diagrams? I don't really know. But of course, they're really using Venn diagrams to talk about things like, oh, wait a minute, hold on. Oh, nope, I'm wrong. I'm wrong. It's 14 points. Not all the questions on this page are about this Venn diagram. All right. But I don't anticipate Venn diagrams being a big problem. I think you'll be fine. Then, I even wrote it in capital letters on the review sheet. Combinations and permutations. They don't give you the formulas. You do have to memorize them. They don't give you the formulas. You do have to memorize them. I don't know why. They also don't ask anything simple like, what are the combination of 7 things taken 3 at a time? They're problems. Like pizza, right? Henny's Pizza offers 12 different toppings and they have a special on a 3-topping pizza right now. How many different 3-topping pizzas can you make? Is that combinations or permutations? Combinations. Combinations are the ones where the order doesn't matter. And you're a pretty damn picky pizza eater if you care whether it's pepperoni, cheese, then mushrooms, or that, whatever, right? I always remember it, combinations are from pizza. Right? You never, no matter how big of a pain in the ass the pizza place is, they don't have different permutations of pizza. Right? They talk about their combinations. Right? Okay. I can remember it that way. Alright. So, like the number of combinations of 13 toppings taken 3 at a time. What is that going to be? Well, damn it, I can't remember. I'm drawing a blank on the test. What could I possibly do to make this any better? We know all of them have, okay, this is N, this is R. All of the equations for permutations and combinations have N factorial on top, and they have R factorial on the bottom. But one, that's all it is, and the other one has N minus R on it. The question is this the right one? We should be able to think this through in a way that helps us remember. Okay, first off, there's just the memorizing. You could just memorize the formula. Okay? But here's the deal. Which way is this? Are there more combinations or are there more permutations? There's more permutations, right? If you're going to say pepperoni cheese mushroom is different from mushroom cheese pepperoni, there's going to be more possibilities, right? So we clearly want this number to be smaller, so we need to divide by more. Right? So this is the one where we need this. Alright? Or you could just memorize it, that's fine with me. So then this would be 13 factorial over 10 factorial, 3 factorial. Alright, which will just be 13 times 12 times 11 times 10 factorial. 10 factorial times 3 times 2. These will cancel out. And whatever, you got 13 times 12 times 11 divided by 6, whatever that works out to. 13 times 22, whatever that works out to. That's how many different 3-topping combinations of pizza Eddie's Pizza has. That's the kind of problem they have for you. If you've just memorized how to do combinations and permutations, and you know which one is which, it will be no problem at all. If you looked at the review sheet, the next thing is probability. Alright, we spent a lot of time in this class on probability. And the Ivy Tech probability problems are not so bad. Most of the points come from relatively simple things. Like the example I gave you on here was, well, I think there are some points that are pretty straightforward. Like, there are 7 students in the class and 2 are boys. What are the probability if I pick a student at random, it's a boy? Okay, believe it or not, there's a little bit just where they're double checking. That's called testing bottom. We're making sure that you guys know even the weakest student in the class should get that problem right. Right? If anybody didn't know that that's 2 over 7, we've identified that there was a problem, right? That's the strategy. So that's the really easy thing. It's more stuff like what you see on the handout about probability. Dave has a 50% chance of wearing jeans today. Bob has a 20% chance of wearing a t-shirt today. What is the probability that Dave is wearing jeans and Bob is wearing a t-shirt if those events are independent? Okay, remember, for independent events, ands were multiplying. So probability, Dave has jeans and let's just do it this way, and Bob has a t-shirt. If those things are independent, it's just the 0.5 chance he's wearing jeans times the 0.2 chance he's wearing a t-shirt, which is just 0.1. If they're independent events, it's just multiplying. Those are the kinds of things. What if it is the or? What is the probability Dave is wearing jeans or Bob is wearing his t-shirt? Well, then you got to use the union rule of probability. That's the probability of the first thing plus the probability of the second thing minus the probability of both. So the probability of jeans was 0.5, the probability of the t-shirt was 0.2, the probability of jeans and t-shirt was that from the previous problem, so the answer is 0.6. That was called the union rule of probability. That definitely happens on the test. I will read you verbatim what I very carefully wrote on the review sheet next. I kind of was very careful about the wording of this. You should always assume that, no. You should always assume I know what I'm doing, except I don't always. In this case, I was very careful about how I worded this, so I wasn't steering you at all in the wrong way. A further note about probability questions. There is at least one question on the test that involves making multiple drawings from the same pool of objects. For example, think about a problem that is involving a laundry basket with 10 white socks and 10 black socks. Imagine that the problem tells you you're going to pull out 4 socks without looking. What is the probability that all 4 socks are white? Notice how that problem would work. You'd have to know how many combinations or permutations, I guess it would be combinations because it doesn't really matter which sock you drew, which one was first and which one was second and so on. How many of them were all whites? Out of how many combinations are there? I'm going to make that sort of your homework for next time, is for you to try to figure out how to make that problem work. Your problem for next time, we have one more review session before the final, is I want you to figure out that bulleted point there that says, like, a further note about probability questions. Next time we get together, we're going to talk about that kind of problem. How would you do something like that? Not that that's a huge amount of the test, it's like 5 points or something like that. If you just got started on it, I can give you partial credit. It's not the end of the world. I don't think anybody's letter grade is going to change over that. But I want to talk about that more. I don't want to talk about it right now, though. I want to talk about expected value of a random variable. Because I remember that folks didn't love that. Remember, expected value of a random variable means that you are talking about, like, what are you anticipating being the value here? You have a what should we do? There's a 10% chance we'll get an inch of snow, 20% chance we're going to get 2 inches of snow, etc. What is the expected amount of snow? We have a 50% chance of no snow. We have a 20% chance of an inch of snow, a 20% chance of 2 inches of snow, and a 10% chance of 3 inches of snow. What is the expected amount of snow? What is the expected value of the snowfall? All right, all you do is you just multiply the probability times the amount and add all those up. Probability times amount, 0. 20% of 1 is 0.2. 20% of 2 is 0.4. 10% of 3 is 0.3. And then you add those up and you get 0.9 inches. Expected value is a sum product. It is probability times that outcome's value, probability times that outcome's value, and then add them up. You do all these products, and then you add up the products. It's called a sum product. I remember for some reason that didn't go very well in the last test. It's not a very hard problem, but you have to remember that that's how it's done. So, I mean, you know, we're expecting not that much snow, less than an inch. In that problem. A lot of things we have done this semester involve tree diagrams. Be able to draw a tree diagram for a problem, putting the probabilities in appropriate places on the tree. Be able to use a tree diagram to compute probabilities and so on. I thought that would be really hard on the last test, and you guys did great on it. I don't know if that's because I had scared you a little bit and therefore you took it seriously, or if that means that you really understood that stuff well and it worked out fine. You can see there's a problem where they give you a tree. It's got numbers on it as well as terms. There's another problem where they give you a tree, but there's no numbers on it, and you have to transfer numbers from the problem up into the tree. I don't know, you guys did fine on that before, but maybe it's because you studied it really well. Don't become complacent about that. Whatever worked for you last time, do it again. A couple quick points, 6 quick points about things like average and median and mode. If you don't remember how to do those things, you'll be able to remember them very quickly with a review, and that's 6 easy points. There is a problem, I even specifically told you about it on the review sheet. There is a problem where you actually compute a standard deviation. We never actually computed a standard deviation by hand in this class because we used the spreadsheet function the handful of times we needed it. But here's the deal. We mostly just worked with a number. We told you the standard deviation was some amount, and we just did it. Here's the deal. It's no huge deal. They literally give you the equation. It's literally just plugging things in. You just take that list of numbers they give you, and you plug them into this equation to get the standard deviation. It's not a hard problem. It's just kind of weird. I don't know why that's on there, but again, I can't erase it. And that is the end of their test. Then there is the part ABSC has added, which in its current form is just this and this, like one more piece of paper. And I'm going to see if I can negotiate it even a little smaller. But we'll talk about that next time, when I actually have more messages from math from downtown and stuff like that. Okay? I'm going to stop the recorder real quick here.